3 years or so since we did our last instruct. It's been a long time. A lot of things that we've done and learned, and I wanted to come back and share those with you. This morning, the Developer's Guide to Docker, getting started with Docker. And I thought I'd actually start with Docker because I've got a series of talks which I'd like to actually leverage off this. So the next talk I want to be able to do is to talk about the ALK stack, about how to mine or log information, and how to surface up that information. It's a talk that I did at DevConf, and I'd want to bring that back into Durban. But before I do that, I'd actually like to lay a foundation with some Docker information because it makes more sense. That talk makes a hell of a lot more sense when you understand the underpinnings of what's actually happening. So this is the start of a series of talks. The next talk I'd like to try and get onto is a Kubernetes talk, just to understand what is Kubernetes, where is it going, what value does it add. And it doesn't help that you don't understand Docker if you don't understand. But to understand Kubernetes, you need to understand a bit more Docker. All right, so that was the point of doing this. Just in terms of the room temperature, anybody playing with Docker at the moment? Anybody read about it, looked at it? Okay. Am I working with generally people that have just not touched it at all? So guys that generally, like this is almost like you. All right. All right, so, sorry. This one first. Before I start, I'd like to just bring to your attention that the Scrubland Gathering is going to be moving from Cape Town to Durban this year. So November the 8th and 9th will be the regional Scrum Gathering for the Scrum Users Group. Just to let you know, we're having it at the Coastlands in Umhlanga. Ticket prices at the moment for the 2 days, because it's a 2-day event, are 2,500. They're almost sold out, so if you want to get in there quickly, $3,000 otherwise. And there's some information if you're a Scrum Mastery kind of person and want to submit a paper. Closing date is the 30th of June. The keynote speaker, internationally acclaimed Esther Derby, has already been booked, and she will be there. So it looks like going to be quite a good event. Just to raise that to your attention, we'll be making more of these known when we get to the other events. All right, so before I start, I actually just want to say thank you to the team that actually makes this event happen. First off, the company gives me time to go and research these ideas and works on giving time to read and supplies me with books and videos and all the rest of the good things that make this talk possible. Our partners investing in some filming equipment so that we're able to film it, and Rory's manning the filming today. It's been very exciting to get there and learn some cool stuff. And then to Lara for coordinating the day. I don't even think she's here. She's coordinated this whole day. I just said to her, here's the dates, this is what I need done. I need some decent man snacks at the table, and that was done. Sorted. Thank you, Lara. You did a good job. All right, so anybody that's done any of these talks knows that I always share some beers or some questions. Give a good question. You'll get a ball. Get the ball, trade the ball in at the end of the day for a beer. Please don't be like the guys at DevConf that will snuck off with my really cool balls. I had these really cool small balls, and they decided they didn't like the beer. I don't know what's up with that. And took my balls instead, battling to find those really cool squeaky balls. All right, Lindt chocolates for anybody who doesn't like beer. All right, so what we're going to cover today, it's quite an in-depth topic, and I'd like to just try and cover a couple of the top level items, just to be able to give us an idea of what Docker is or what it isn't, and some of the flexibility and power that we've got associated with it. So we'll start off with an introduction to Docker, a little bit of a story as to why we do Docker. These are not in order. Actually, they were in order. I was going to do Docker internals and then build a container, but as the talk progressed, it's made more sense to build a container first and then look at the internals afterwards, so that we could compare with what we had seen to what I was going to use, sort of a theoretical thing. Then understand what the persistence looks like inside Docker. Understand a little bit of networking. I'm not going to touch on that too much, but it does set the platform for my next talk, so I did want to get it in. And then to understand what is this concept called Docker Compose. We'll get to those as we go. So 4 large topics to cover. One, the first topic is probably where we're going to spend a fair amount of time in this talk today. So why learn Docker? Why even use it? Why consider it? What is so special about it? I thought I'd tell you two quick stories to give you my introduction to Docker and my feelings to how it's helped me on a daily basis. All right. So the very first time I came across Docker, I was actually reading a book called Irresistible APIs. And the really cool thing about the person who had the author of Irresistible APIs is that she had actually created this API test application and she put it in a Docker container. And while I was working through the tutorials inside a book, all I was doing was pulling a Docker container from the Docker Hub. And I was actually running this application on my machine. I could connect inside it, I could have a look at the code, I could start playing with things, and I was like, wow, this is actually pretty cool. There's this technology that somebody can prepare for me that I can actually pull, run on my local machine, and actually work as if I was working on their machine. So that was just this amazing connection to just the power of Docker. And it wasn't even the main intent of Docker, but could you just imagine how I don't know, it was just an amazing moment for me to find tools that would allow me to do that. And that metaphor for being able to run anywhere, anytime on any machine is an amazing metaphor, which carries itself forward into taking things to the test environment, taking things to the to deploying things to a production environment in a self-contained container, knowing that it's always going to work. And then the other side to this is I'm always playing with software. I'm always playing with new toys. I'm always trying to understand new technology. And hands up anybody who's tried to put up a new piece of software, like let's say Elasticsearch, for example. Anybody tried to configure Elasticsearch on their local machine and get it running? Elastic's a pretty cool tool. It's relatively easy to get running, but it does have some caveats. You've got to get the right JVM, you've got to make sure that there's a certain configuration, you've got to download and install in the right directory, you've got to make sure the configuration is working correctly. It's well documented, but generally you have a problem. And with Docker, somebody's already done all of that for you. It's a self-contained element. You pull the Docker image down, start up a container, and it's running like super quickly. And we're going to do that right now. I'm going to show you exactly how quickly it is just to get Elasticsearch running on your machine with 2 lines of code. Right, and that for me is one of the reasons why I like using Docker. Right, there are a number of other reasons, we're going to look at them later, but those are 2 personal reasons for me. Right, so let's run some software. What I've done is I've actually gone and done a pull from the Elasticsearch public Docker registry for their Elasticsearch application. I've actually pulled 3, but I pulled them for a particular reason, and this is something that will become evident a little later, but I just wanted to note the slide. So I'm going to pull. This is how we get an image onto our machine. You do a Docker pull from a particular registry, tell it what you're pulling, and it will pull the applications down, pulls them in these little layers, all right, and then registers them on your machine. I did a pull for Elasticsearch, Elasticsearch open source, and Elasticsearch Platinum for the different versions of the software. You'll note here that as I pulled it, you'll see that this layer was pulled down and it already exists. And this is a very important aspect of Docker. We're going to get into it, but I just want you to take note that Docker's using this layered architecture, and so it doesn't matter. So if you have a particular layer on your machine, it's actually going to not worry about needing that. And we'll talk lots about that later when it comes to disk space on your actual host machine. All right, so let's do some software. Okay, so bear with me. All right, so I'm going to run a Docker command. All right, so can everybody at the back see? Is this clear enough? All right, so essentially what I'm telling Docker to do is I'm telling it to run. I'm giving my container a particular name called Elasticsearch. Sorry, is this the right? Okay, let's ignore that. It's not exactly what I want to do, but I'm going to tell it to go and put some data on a local drive. That's not really what we need to do right now. I'm going to expose some ports. I'm going to set some local variables, and I'm going to tell it that I'm going to use this Docker image to run. All right, so we're just going to start that up. All right, so now Elasticsearch is starting. And while that's starting, I'm just going to go and connect to it. Alright, and that's just basically doing a quick call to Elasticsearch on the port that's been exposed. And if you see, you know for search, basically Elastic is up. Alright, so that's me done. I have an Elasticsearch instance running on my machine. I didn't do anything very much. I pulled a container from the Elasticsearch store. I started up Elasticsearch. I just went and read a little bit on their documentation to understand a couple of the variables that were being put in there. And I did a quick curl and connected into it, and here we are, Elasticsearch up running on our machines. Okay, like, I don't know, it's like almost trivial trying to get started on some new software. We'll talk a lot about the hub later and exactly what software is available on there. Some interesting things that we can do with this container. So I can go and snoop around, can actually connect onto the container. So what I tell Docker is that I want to execute in interactive mode using some sort of using the standard input output on that particular container, and I want to run the command bin bash, and now I'm able to get inside the container and I can list and I can see what services are running, and I can basically understand what's actually happening on the container. So I've got quite a lot of power available to me. All right. Okay, I'm going to stop that container, remove it, because I think we've done that. Stop this container. Right, Elasticsearch is closing down, and I'm going to remove the container because I need to do that a little later. Done. Okay, so that's the very first reason why I think developers should actually start getting to understand Docker, because it's really quick and easy to pull a container down, read some of the documentation, start it up, and I'm up and ready to go. All right, let's carry on with the talk. All right, so run some software is relatively easy, and for me, if you're starting with Docker, this is the first place that I would suggest you try and get started. I know that Docker is touted as we can do some really cool microservice architectures, and it's just like this great barrier to entry when you start getting into that, because you've got architecture to think about, and you've got like how are we going to construct the code, and what code am I going to do, and I need to understand all the different elements. It's like, well, don't bother about that. Just start using Docker on your local machine to run the applications that make your life a little bit of a hell, all the applications that need to be run on a remote server. Right, so I've gone and done a list of about 11 or so, and I think we could make tons more of the reasons why, the things that you could do with Docker. First off, we can start using it to replace our virtual machines, and we're going to talk a little bit about why Docker is different to a virtual machine. But suffice to say that a virtual machine takes a long time to create the environment. I've got to set up the OS, I've got to then configure all the applications on that. With Docker, that starts to be removed. All right, virtual machines are also substantially larger and a lot more complex, a lot more resource hungry than Docker containers, and we'll look at that just now. If I want to prototype some software, I can put the software inside a container and it's self-contained, doesn't have to affect the rest of my application. I can package some software, so being able to take an application and give it to somebody and say, yeah, this is what I was doing, this is what the application is. It's really cool, and we're going to actually have a look at a piece of packaged container software now. Enabling full stack productivity when you're offline. So on the applications that I work on at the moment, the full stack application requires probably about 15 or 16 moving pieces, from RabbitMQ to Solar to Elasticsearch to I don't even know, Kibana, Logstash, a truckload of different pieces of software. And in order to be able to run it locally on my local machine would actually be a mammoth task. But with Docker, I'm able to actually set up and run on my local environment, something that close to simulates the production environment. Because of that, it's reducing my debugging overhead. I don't have to do any remote calls to things. I'm actually just running locally on my machine. I can attach to the containers if I need to. You saw me attach to that container. I can look up the container. I can follow what the logs are doing. And I can literally figure out what I'm doing on a local machine as opposed to having this very complex piece of software spread out all over the place. Another really interesting thing is to create repeatable support processes. So on the project that we're working on, if we need to create dashboards or if we need to do some code generators, those are all inside a Docker container, and all we do is spin up the Docker container, point it at a directory, container runs, does some code generation, shuts down, and then goes to sleep again. And I can actually take that container and give it to somebody else and say, here, this is the tool that I'm actually using. We also use it for backing up, for example. You know, if you need to do a backup and it's a particular command that you run, spin up the container, it connects to whatever it needs to, and then runs and backs things up. And I'm not talking about SQL databases and that type of thing, because that's relatively easy, but about moving files and collating and putting information across. It's really cool for modeling networks. We'll see just now how powerful the networking actually is, and you can actually model small network environments inside your local machine. You can split things off into different subnets and let them talk to each other and understand how this thing is actually going to work. We talked about enabling the microservice architecture, so that allows us to get there. And you'll notice it's way down on my list of really cool things because it's very powerful there, and we'll talk about that when we get to this Kubernetes conversation, but there's so much more you can do with it before you start getting to microservice. Enabling better continuous delivery. Because we're able to self-contain our packages, we can actually just push them onto servers relatively easy, so continuous delivery becomes better. We do this a hell of a lot, creating test jigs. So as an example, one of my staff members had to create an application where they pushed an item into an FTP server. Okay, like how many people have FTP servers running on their machines? Like how long ago did we actually interact with FTP servers? Well, they had to do this, and the easiest way to do it was to actually create a Docker container that just had a simple FTP server, and all he was doing was pushing this stuff up to the FTP server. He wrote a small little node application that could actually manipulate the data, put the data into the correct space, and now he had simulated exactly what was happening on the service provider side. So that's super powerful. The other interesting thing, and the outset, is that this actually starts enabling infrastructure as code. We're going to start looking now. You can actually now document how you're building your containers. You can document parts of your process and check this information into a source code control and have it repeatable over and over again. So you've heard my talk about creating database artifacts as code. Well, now we start enabling infrastructure as code. So repeatable processes over and over again. Anybody got any questions at the moment? I was happy for you to slow me down and ask questions as we go along. All right, one thing that I didn't say. Happy to answer questions as we move. All right, so before I start, we're going to build a quick container now just to show you how simple it is. There's some key concepts that I wanted to get across before we moved on there. So the Docker environment at a very, very high level is made up of some elements. The first element is the items that sit on your host machine. So there would be a Docker client. That's that Docker application you saw me connecting with, that Docker run, and you tell it which container you're actually going to run. So that's me connecting to the Docker daemon, which is just a service that sits on the back there. Well, I say just a service, and we'll dive into the underpinnings of that service. is very, very powerful in terms of how it isolates containers, how it manages security, how it sets up memory access and disk access. So there's a lot going on under the covers, but understand that there's a service on the back that we would connect to. That service in turn would be able to connect to Docker registries. We can't do anything on Docker without starting with a base image. We'll take a look at that now. And these images are kept in a number of places. You can keep Docker images locally in a private Docker store, relatively easy to get up and running. You can get images publicly. You noticed I got the public image when I ran that from Elasticsearch, or you could go to Docker Store / Docker Hub to be able to pull images directly from Docker. If you do a pull from Docker and you don't state the URL, Docker automatically goes off to Docker Store or Docker Hub and pulls the information from there. So what is the difference between store and hub? It's an important thing because it's relatively new. Traditionally, we always had Docker Hub, and this was basically a space where people could push their images and share their images, pull them down, and be able to work with them. But the downside of that is that anybody could push anything, anytime, anywhere, and it's not really trusted. All right, and so the Docker boys created the Docker Store, which is a bit more of a trusted environment. It gives you an ability to push an image up there and charge people for the privilege of using it. Images generally in the Docker Store need to go through a vetting process to make sure that they're actually a bit better than what people say they actually are. And so there's more security here and less security here, but you're going to find there's a lot more activity happening in the Docker Hub. With Docker Store also, they don't really do tags and things like that, so Docker Hub will talk about that later, but you can tag a particular version and say this is the version that I always want to use. With Docker Store, as far as I'm aware, we're always using the latest version of that particular image. All right, so some important things to get together. We have to start building a container with an image, which we will pull off one of these sources, generally this source. We will interact from our client into our service or daemon to be able to create an image.
Sorry, Chris.
Yeah.
What's an example of a private Docker registry? Would that be like a Nexus type thing, or is it a separate app that you'd have to install?
So a private Docker registry is basically creating a registry locally inside your company that you push your Docker images into.
An example of that type of software?
It's the Docker registry.
Oh, it's actually Docker registry.
It's Docker software that runs on Docker.
Oh, okay.
So it's a Docker container, just basically called registry.
Oh, okay.
And you fire it up and you just push directly to it. I can show you, I've been fiddling around with a few of them, so I can show you a little bit later if you want to do that on an offline conversation. But the idea here is to be able to create your Docker images locally, because sometimes people put private information on those Docker images. They don't want to have to publish them. So on my team, one of the things that I've done is a really cool Docker container is that I've got a tool to document all the databases, and I push that into an Nginx Docker container, which basically serves up the database as a website. And so you can click on the databases and understand which sort of procedure needs to go to a private registry. I can't send my clients 20 or 30 databases with all their data structures up into the cloud. It would be a little bit of a problem. But then there again is a nice example of how we're using Docker to be able to transfer information backwards and forwards. All right, any more questions? All right, so how about we start building an image? All right, so we're going to close this down. I'm going to create All right, so to create a Docker image, we create what we call a Docker file, and this, as you can start to see, is the first part of infrastructure as code. So this is telling me how to build my container. I check that in, it's under source code control, it's a repeatable process, everybody has it available. And essentially what I'm doing is I'm creating a simple node application, and we'll have a look at that node application now, but I'm creating a simple node application, and I'm using the image node and the tag version 8.11. All right, so Node 10 is out at the moment. I don't want to be running around, fiddling around with with version 10, so I didn't want the latest. So this particular point, just a note, so that's the image name that I would have pulled off Docker Hub, and I'm telling it that I want the tag at 8.1. If I just put node, then it would have gone and got the latest version down for me. All right, so the first thing I need to do is this from line, which tells me which image I'm using to actually build this container. Then some information about me. I just added that in. You don't generally have to put that in. I added it in because I just wanted to be aware of some elements. Then what I'm going to do on this new image is I'm actually going to add a new directory called app. And then I'm going to copy my application code into that app folder. And I'm going to set my working directory, it's an environment variable for my Docker container, set my working directory to app, so that whenever this container starts up, it goes directly to that directory straight away. I'm then going to expose a port 8080 so that I can now connect onto this. And then I'm going to create an entry point so that Docker knows that when this container starts, this is where it needs to go. You can run commands and all kinds of other elements in it. I'm going to create an entry point and say, I'm going to go and run node, and the application that I need to pass is app.js. And that's a simple node application on a container. All right. Traditionally, you wouldn't really want to copy the code off your local machine. Traditionally, what we do is we run commands to pull the code from a source code repository in Git, for example, and you can actually do that. It's just a command, git clone, give it the directory, pulls the information down, and it will run. All right. So we're going to go ahead and run this. If this image was not on my machine, it would have connected to the Node Hub, pulled the information down, but it is on my machine, so it's just going to take whatever version is on there now. But the really powerful thing about this application, and especially if you've got it connecting to code that's in a repo, is that this thing has no other dependencies other than stuff that's away from the local machine. That becomes a very powerful way to write your Docker files. So what is this really cool Node app that I'm doing? It's really, really sexy. Okay, so it's a very simple Node application. All I'm doing is creating an HTTP service. I'm needing some OS information. I'm doing some logs. I create a server and give it a callback to a handler. And I need to listen on port 8080. And when I get the information coming in, I log some information that says this is where I received the call from. I write a status code 200 to say that I was successful, and I give it some information to say that I've hit this particular host name. Okay, nothing really complicated, but I mean, I needed to give you a bit of an example. But that's a simple Node application, and we're going to quickly build the Docker image off that. So I'll just get my commands. All right, let's go down here. So what is it going to do? We're going to do Docker build. I'm going to tell it that this is the name of my container, and I'm going to tag it as version 1.0. Note the little dot at the back always has to be there on the build command piece. It's like the most common mistake you'll make. So, what's happening? Okay, sorry. I've done this specific one, so we're going to go here. Have to be in the folder. All right. So essentially, what it's doing. It's looking for the Node version, the base image that I'm using. It's then going to create individual images as it goes, individual layers. And this is important. It's creating a series of layers. So it creates an image, creates a layer on that, which is a delta from the image, which has got the app directory, and then creates another layer on that, which is a delta from that, which has the copy on that, and it's just creating these layers on layers on layers. And so it's not actually touching the node image, it's actually just creating these layers which are deltas between each other. And then when I create a container, it bundles all of that up close to each other, it knows what the references are, and then it has its way of operating. Okay, we'll talk a little bit about that, but it's very not, and it's not really the topic for an introductory conversation. But there we go. We've created a Docker container or a Docker image. If I just do Docker images, you will see I've got a whole lot of them at the moment, but here's the top one. Here's the image that we created. All right, it's 630 megs. I'm not entirely happy with that size, but that's because the base image is 630 megs. You'll see some of these other are quite a lot lower. I want to just touch a little bit on that when we get there. All right, so we've created ourselves an image. All right, but an image is useless if we don't actually use it. So I just want to quickly go and run my container. We can do that here. All right, so what are we going to do here? We're doing Docker run. The -d says I actually want to run it in disconnected mode, so I don't actually want to see what's happening. It's going to go and run in the background. I'm going to call it my app 1. I'm going to expose ports 8080 and I'm going to map to 8080. And I want to use the image my app with the tag 1.0.0. And that will be up and running. All right. And if I now quickly curl off to it, you'll see we get a response. We've hit some container number. All right, so it's relatively trivial. It's not a most advanced example, but I hope you get the idea of how simple it is to create a Docker container. What I want to do is I actually want to start up another one. So I've actually taken that exact same image and I've started up a new one. And I'm just going to list, and you'll see I now have two images. They're both using it's two containers. One is called my app 1, one my app 2, and they're both using the same image. And if I curl to that, you'll notice that they are at different endpoints, so they're in different self-contained elements. All right, so that's how easy it is to get a Docker container up and running. You can understand why we start throwing these things around and just putting documentation inside them and sharing them with everybody. All right, just stop my containers. Alright, so we built an image. We've run some containers. Let's move on. So what exactly were we doing here? I kind of explained it while we were going, but here's an image, here's a more mental image or picture of what we're doing. So we took this image, node 8.11, and then we applied some changes to it, and these became layers inside my Docker ecosystem. Right, so there's layer 1, layer 2, layer 3, and as you make changes, you have layers. This image and these layers combine to create a brand new image called my app, which had node 8.1 as part of its base, part of its reference. If I gave this image to somebody else, then actually don't worry about that. Okay, so we now have an image, which is the definition of all of these elements. And when I started up my image, I start my containers off a particular image. So containers and images are separate concepts. Images are the things that we use to create containers. They are the definition for what is actually running in the container. But the other part of the definition that is on that container is the information that we give it on the command line. What ports are available, how is it supposed to run, any environmental variables, what its entry points are. So we could define those, and we're going to start looking at a little better way to define those as we go along. But those containers are instances of that particular image. So if you think about this in an OO perspective, you have a class which you define, and you can create more than one instance of that particular class. And so this is the class that you define, like how this thing looks and behaves. And when you create an instance of, let's say, I had a file handler class, I could create two separate instances of those file handler classes. And that's essentially what I've done with those containers. Create two separate instances. They have their own memory, they have their own management. All right, does that settle with everyone?
So a question, so for each container, if you've got apps running on there and they write their own log files or whatever, you can stop and start that container and it keeps its state?
Yes.
Right.
Yeah.
Can you back that up?
So we'll talk about state. Yeah. So it's a good question, and you can get a ball for that question. Yes. All right. So state is really important. We're going to get there, but let's talk about it while we're there. So as long as a container is on your machine, the state is maintained within inside that container. So the data is writing inside that container. As soon as you take that container off, the data is gone. All right, so everything is self-contained within inside that container. You're going to say, well, that's useless, and it pretty much is useless. But we'll talk about persistence layers and how we manage persistence layers, because crew at Docker go, well, we need to be able to do that. But the stuff inside the container, that state, is only available in that space. All right. And you don't generally move containers from place to place. You move images from place to place. And so there are ways to back up. You can connect to a container and you can copy information off the container. But it's statically. There's better ways to be able to do that. Answer your question.
Yeah, just when we were pulling those various versions of Elasticsearch, we were seeing those layers.
Yes,
okay.
exactly. Yeah, so nice tie back. Nice, thank you for creating the connection for me. All right. Yes, those layers that you saw with Elasticsearch is that the team at Elasticsearch had 3 layers that we used consistently across all 3 versions of their Elasticsearch. And so when you pull Elasticsearch down for the first time, you get all 6. And then when you pull the open source version, it's only pulling the next 3. And when it runs, when that image runs, it takes the 2 that were pulled down, the 3 that were pulled down first, and the other 3, and then it's got those elements. And so you could appreciate now that we actually have, we're starting to save disk space, like hugely save disk space. I don't, to give you an example of how powerful running these Docker containers actually is, one of my teams created a little application, microservice-based architecture, and we're really careful about how they actually managed their space and reduced the client's hosting costs by 50%. All right. So most people go, well, I don't really worry about the size of disk space. I got into this really crazy argument a couple of weeks ago with a good friend of mine and saying, I don't mind if my image is 9 gigs, and I was arguing for a 20 meg image because I've got enough disk space. But when you run into the cloud, you start paying for everything. And a 9 gig disk space takes a long time to push, so that's bandwidth, and it takes a long time to start up, because that's CPU time, and it takes a lot of space inside your disk. And when it's started, it takes up a truckload of memory. So those are things you have to think about when you're writing things for the cloud. And Docker is the way of getting into the cloud. We've got to think carefully about that. All right. So what that leads me into is this concept that they have in Docker called Copyonwrite. So it's essentially what they're doing is they're creating an image, and then any changes to those images are just small bite-sized chunks. Instead of copy on startup, so when copy on startup would mean that I have to go and find all the different layers and put them all together, which ends up being a large amount of disk space and a large amount of memory, which is largely what we've been talking about now. So it's just an important aspect to remember. All right. So what's happening underneath this thing? And I don't want to go into too much detail, but I want this segues into an interesting topic around do you run this on Windows? Do you run it on Linux? Do you run it on Mac? And we'll get to that conversation soon. But I just wanted to talk a little bit about the Docker internals. Docker internals are leveraging off a key element of Linux kernel libraries and concepts that are applications and things that have been building up over a number of, I guess, decade or so. Even more, actually a number of decades if you go and look at the history of where LXC came from. But essentially, none of this containerized concept could be as simple as easy if we weren't running on a Linux environment. All right, so the containerized applications, LXC, systemd, nspawn, the Vert, these are all elements that give us the containerization inside Linux. In the kernel, the C groups and the namespaces are the elements that give us the ability to create a container and ring fence its memory, its disk space, its disk access, and ring fence its, just basically create space inside the kernel on the actual host operating system that is not touched by anything else. All right, so that's pretty important because that differs from a virtual machine. A virtual machine is I create this space that nobody else can get onto, and it's an actual operating system. And when a virtual machine starts up, it will need to run through the entire process of an actual startup. When a container starts up, it doesn't. It actually just spawns off a new thread and connects to that thread. Because it's got C groups and namespaces, it's now able to manage its memory and its disk access and all the rest of the nice things that you need in its own space without anything else being able to touch. So it makes this application super fast. Capabilities and app armor start to give us the security that we need so that you can't get access to that space in memory and disk. Netlink and Netfilter gives us the ability to start giving us network security. This all combines to give us what is now known as the lib container format, with making use of namespaces, C groups, and this union file system, which is also important, is taking it, being able to create a base image and then layer on top of that those deltas. That union file system together creates this lib container standard, and this is the standard which Docker has brought onto the world and gives us the ability to be able to create this containerized application. So what that gives us is a self-contained application with process isolation, resource restrictions, and then we're able to share these images as we move around. All right. So that's where Docker starts to differ from a virtual machine. So I just want to bring that home again. Virtual machines are actual environments with an actual operating system that needs to boot and you install all your applications on there. Docker is a simulated version of that environment, which takes a container, defines the boundaries using C groups and namespaces to say this is the resource, spins off a thread off the main operating system and attaches it. And that's one of the reasons why when we started Elasticsearch up there, we saw how quickly it actually started. It took a couple of seconds to get, 10 seconds maybe, to get up and running and going. Whereas if I started that on a virtual machine, I'd have to boot the virtual machine. And then I'd have to make sure that Elasticsearch actually started. All right, so that's one of the key powers that we get out of this environment. Questions on that before we move on? All right, nothing. Persistence. All right, so to your question, what the hell happens with this container? Yep, containers, if you have them and you don't actually have the volume, data volume that you're writing to, it will write all the information to that container, and when you delete that container, all your information is gone. This makes it really powerful if you're just testing stuff. So I want to fire up an application, I just want to be able to set up a particular database, I want to push some information into a store, I want to play with Elasticsearch, and then I want to tear the container down and start it back up again. That's really great, but as a production environment tool, that's pretty sloppy and sucks. Right, so Docker has given us the ability to connect, and there's a number of ways to do it. And we'll talk a little bit about the newer ones and the older ones. So in this picture, we have a container, and Docker gives us the ability to do what we call a bind mount. So I can actually mount a directory inside this container to a directory on my host file system. Right, and you saw me getting a little bit confused when I looked at the run command earlier. It was because I had a command with bind mounts in there, which should probably not have been there. But yep, that's the way, which is really just basically saying I'm going to map the directory that this container needs to a directory that's actually just on the host operating system. And so now I can start writing my data, or I can get my log information, or I can get configuration information from the file system. Right. But bind mounts are dirty, they're not consistent, and they are prone to some trouble when we're trying to share data across many containers. All right, so what I mean by dirty and inconsistent is if I take this container and I run this container on a Windows machine, and I have bind mounts that are bind mounts for a Linux machine, it gives me trouble. All right. It could even give me trouble between different flavors of Linux. All right, so if I was running on, I guess, between Ubuntu and Red Hat, there are some differences in file structures and things like that, that potentially could give me some trouble. Flavors of Linux Arch and the rest of it, you start running into even more trouble. All right, so bind mounts are handy if you're just doing it onto your local machine and you just want to be able to fiddle and play, but it's not the suggested way to do it. The suggested way is to actually use the Docker volume. What Docker volume actually is it creates a space inside a fenced-off Docker environment, actually just below where it's actually running. I think it's vars, shares, volumes. We'll take, actually, there it is. Vars with Docker volumes, and then underneath that, each Docker. So it actually creates this space. But this space is managed by Docker. So when you create the volume, it knows to go and create it on the disk, and then you just bind that container to that volume, and now it's managed inside the space of Docker. This means that I can take a container and I can give it to anywhere. You can run on Linux, it can run on Windows, it can run on Mac, and it doesn't matter what the external file system is. Docker's going to take care of that for me. All right, so that's an important element. There are new ways when you connect. There's the old -v, which is this is how the volume connects, and they've also got the new mounts option. Mounts is a lot more verbose, so you tell it what the destination and the source is, and volume connection, although they do exactly the same thing, has a bit more of a terse way of getting into. The other interesting thing with volumes is that if the directory doesn't exist in volume, it would automatically create it, whereas with mounts, if the directory doesn't exist on the host machine or on the environment, then it actually pitches in complaints, which is quite nice, depending on what flexibility you want to have. You can also create an in-memory space, so you just use temp.fs. The only problem is that temp.fs is only available in the Linux environment, so just use that carefully if you're a Windows person. That option doesn't exist for you. And what I have also included here is the old way of connecting, just in case you see it out in the wild, because I still see it quite regularly. Volumes haven't been adopted as quickly as I thought they would be. The old way of actually connecting to a data container was to actually create a container that really just mapped off, you create a container that basically exposed a particular endpoint, and then when you started this container, you said that this volume needed to use, this container needed to use this container as its data volume, and then it automatically mapped the information into Docker. So this data container, volume container, and then the actual container was an old way of doing, old way of running your containers. And I thought I'd just include it just for completeness, because you may still see this out in the wild. All right, so let's just have a look at some container. This. All right, I've already run this command earlier, so I just wanted to actually pop in there. So I ran this I ran this command earlier where I actually, this data container would have been empty. When I started up my container, you can see I'd mapped, I'll go through the command, but I'd mapped my, my Docker container to use this share Elasticsearch data, which is essentially what it was looking for. If you go and have a look at this, you look at this line, this point over here, which is saying, on my host machine map uses share elastic data to use the shared elastic data inside the container, and you can see it actually just started up, connected, and wrote. That's just the -v to say that's the volume that I'm using, and that's how simple it is to map to a local bind. All right, but local binds are not the greatest, and so volumes are probably a better option. So. So all I've done now is to actually create a volume that I'm going to use, and it's quite simple. Docker volume, create volume, give it a name. So Docker volume create, give it a particular name. And what Docker's done underneath is it's actually going to reserve the space inside its own space for me to be able to use that volume. Right, and okay, yeah, so if we wanted to just list the volumes. Go. Okay, I use volumes quite a lot, so here's the demo volume that we've just created. Right, and so what I'm going to do here is just take the elastic test out because I think we've already done this. It's not there. What we're going to do here is we're going to run elastic test. You can see here we're going to map our volume, local volume, to whatever data we need Docker would write to internally expose the ports using the image to start running. And that should just, I mean, there's nothing more than that to show you, but I mean, essentially it knows that it can connect in. If it wasn't able to access the volume, then you wouldn't see, there's an element here which we're waiting for, which would just say it's gone from yellow to green. There we go, healthy status changed from yellow to green. So it was actually just writing out the nodes and all that information. And we know that when we see this, we actually have our Elasticsearch nodes up and running. So the information's been saved to the local volume. All right, any questions? Right, I'm going to move off Docker persistence. Are there any questions?
So just one more session going back earlier, you explained the difference between the VM and the Docker.
Yeah.
And you're saying it doesn't start up an entire operating system. Does that mean the images are they sort of operating system agnostic? So you create an image and then you deploy the container to Linux or Windows?
So not entirely. So you're always going to need a Docker ecosystem. And yes, the images are agnostic, but on Linux it's a lot easier. You just install. We'll talk about it a little bit later, but we install Docker Community Edition, and we have Docker available to ourselves. With Windows, it's a little bit more difficult. You actually need the Docker tools for the Docker for Windows application to be installed in your application, and then it doesn't matter. Then you can share images all over the place, but you do need an ecosystem installed on those environments. So it really is just a Docker application that needs to be there, and then it becomes agnostic.
Yeah.
All right. It does open a little bit of a trick, and one of the things I want to encourage you is if you're going to get into Docker, do it feet first. You're going to need to understand some Linux, and most of those containers, most of the best containers are Linux-based containers. Now there are Windows containers, and I'll talk a little bit about those later. But I would suggest that you get into, and this is a nice way to start getting into Linux. To get onto the command line, understand a bit of bash, be able to list some stuff, be able to move around, because most of the powerful containers that you're going to write are Linux-based. Most of the tooling that you can get out there is always going to be in an open source Linux-based environment. All right. But I want to get there because there's some slides around that. Okay. Moving on. persisted some data. All right, moving on to networking. I don't want to spend a hell of a lot of time here, but this does, as I said, segue into the next set of talks that I want to do. Guys, we've just got networking, then we've got Docker Compose, and then I think we're pretty much done. So bear with me for the next 10 minutes and we'll be wrapping up. All right, so Docker security, from the strongest to the weakest, and these are only 3 of the elements that I had that I wanted to bring to your attention. There is a way of starting a container. Okay, wait. First of all, let's start. So there's the closed container option. There is a bridged container option, and then there's an open container option. Bridged container is the default network option that we have inside Docker. Closed container, absolutely no connection to the outside world. You start up the container, nobody can get in, nobody can get out. It does what it needs to do, it shuts down and goes away. We generally use these things for backups, for running particular jobs that we don't want people to get involved in. They're really cool if you're running inside the cloud and you don't want these containers being exposed to anything. So these are the things where you actually have it doing some heavy lifting for you. All right, so that's where you would use it. Not very often, but we use it from time to time. The bridge container, this is the default mode. And so what it actually does is it creates a private connection into this container virtual interface, which then creates a connection into the Docker bridge. And the Docker bridge is the element which allows us to connect with the outside world. So each of these containers will get their own IP address, and Docker will manage it. So if we started a container, if we started 2 containers, they would each have their own internal IP address, and the Docker bridge would then do the netting and all the network translation for you inside. And then there's the other option, which is open container, which avoids all of this and goes directly onto the host's machine and exposes itself directly to the host. Okay, super, not so secure, but this option is available when we start swarming the elements. So Docker has a technology built inside it called Swarm, which allows you to create more than one version of that same container on different machines and coordinate what it's actually doing. And it uses the container for that. All right. So there's a whole lot of other information about it. You can give containers their own MAC addresses. There's an overlay architecture for Swarm. I don't want to get into it really. All I wanted to be able to say is that there are some ways in running your containers securely and not securely. Most of the time it's in a bridge container, and this bridge allows us to give this container a name and map the name to a particular IP address, and containers can actually, if they're on the same bridge, can actually talk to each other. So we're going to talk a little bit about that. The reason why I wanted to raise that is because it raises the awareness for you in the next talk that I'm hoping you will attend, when we talk about the Elk stack, which has Elasticsearch and Kibana and Logstash all talking to each other, and they need to be inside their own private little network. And that's why I raised this.
Those closed containers, can they still access your persistence and your buttons?
Yes, yeah. So persistence happens that way,
yeah.
if you thought about it. And this is the front way, so this is what's front facing, yeah. So these, yeah. Okay. All right, so I don't know if it's worth the demo. I included it in the demo just to show you a little bit about the networking. So how do we start a container up? How do we start a container up in a network mode where it's so secure that nobody can connect to it? --net none. All right, if I run this is just a simple Alpine container. It's only a few megs. And what that's going to do is just to show you that it's actually just got loopback available to it. So it's got absolutely nothing available inside the networking environment. All right, so if you wanted to start up a container and you want it completely contained with security, --net none, and we sort it out. The default is bridged. You'll see now we have loopback, which is 127.0.0.1, but we've also been given an IP address, 172.17.0.2, and Docker's taking care of that for us internally. All right, so if I go to that particular container and I map into it, then Docker knows where to actually go to it. All right. We can give our containers a host name. We're just really scratching the surface here. But essentially what is happening is that this container now has a host name called Barker, and when you look up Barker, it's 127.17.02. Giving this container a host name means that other containers can now talk to it on the same network. All right. And then I just want to do an open for you, just to show you exactly what happens when we open it up. That's opened up. That's every single network access point on my machine. Right, so you can see it's actually skipped all the Docker stuff and gone directly to the network access point. All right. So I don't want to dwell too much longer on this. But I did want to show you this. I actually just wanted to. So the interesting things about the networking port parts are where we expose the port. So you saw some other networking, but this is generally the most important aspect that you need to do, is know which ports we're mapping to. So Elasticsearch has 930 as the back channel and 920 as the front end, and we're mapping what's on the host side to what's on the outside. Generally, when you're trying to connect to something and you're not getting it running, you'll find that it's because you haven't exposed the reports correctly. All right, so just to take note, this is generally a newbie problem. All right, I'm not going to go through this entire process, but creating my own little network. So Docker has a bridge 0, which if you don't connect to it, will create your own network. Then everything will go through bridge 0. But you can actually create your own network by just doing Docker network create my net, and actually just saying this network is the network that I'm actually using. And I could then start up a number of different containers, telling it which network to use, and they can all connect and talk on that particular network. All right. The old way of doing this, and you may still see this out in the wild, is that we used to create linked containers. And so you'd start up a container and say this container links to this container and it links to that container. That linking way is actually being deprecated, and it's been replaced by creating a network, actually just connecting on the network and then connecting all the way, connecting to each other through the network. Okay. And because these elements are named, those names serve a purpose inside that network. Does that make sense? Right, so we've done some networking. I want to move on to Docker Compose. So anybody's been watching me do this thing, and the reason why I've actually cut and pasted these things is because they are so dog long. Those command line elements are so dog long to actually get started. And they can get, if you're starting with a very complex application, they can get really, really tricky. And making one small typo ends up with little lots of tears and trying to figure it out. And so Docker team have created this concept called Compose, which is so much more super powerful and easier to understand. So let's have a look at a Compose file. So here's a Docker Compose file for the elk stack. And this is leveraging off what I'm hoping to do in my next talk. Here's an intro. So the container is just, the file is just a simple YAML file. But it's given us all the different elements that we would have needed to type in on a very long command line. It's given us an ability to now define our application in this really easy to read, human readable format. Right, so we have a version, so this will tell us what version of Docker Compose we're using. Different versions of Docker can only run with different versions of Docker Compose. So you've got to be careful. You actually install Docker Compose, so there will be different versions of Docker Compose out there. Just find the version. Elements like depends on are only available in version 3, for example. Version 2 has elements, and version 1 has other structures. So just be aware of the different versions, and the versions change relatively quickly. So there are features that you may be familiar with that aren't available in other versions of Compose when you go to somebody else's machine. Right, but the basic structure is these are the services that we're going to have in. So I'm going to have an Elasticsearch service that's going to run on the open source version. It's going to use the image this is the image that we need to start up the container. These are the volumes. So I've created myself an OSS data volume inside Docker, and I'm mapping where I'm writing my Docker data. I expose my ports, and this is all going to run on the in the OSS network. All right. If you have a look at my Kubernetes, my Kibana, it's going to pull Kibana image. These are some environment variables that I actually need. This is so that I know where to actually go to Elasticsearch. There are my ports, there's my network, and I'm depending on OS, and there's my log stash, and we'll get into the conversation on this in the elk stack. And now I've defined my volumes and I've defined my network. And I have a much neater and simpler way to define how my containers are going to start up. All right. And if you have a look at this, everyone's using the same network. So this all three of these containers are going to fire themselves up, have their neat little spaces to work in, but they're all going to be able to talk to each other because they're on the same network. Right, so that's the power Docker compose.
Chris, that depends on what does that expose from, like, I would say, is that the parent container exposing ports to the bottom containers?
So
what capability does that offer?
It's used more in the swarm-based environments, so that these elements know that this is supposed to be up before that is supposed to be up. But it doesn't do much else than warn you that it doesn't have anything else there. So I was just fiddling around with it when I did that. When you read it first, you think that, well, that's got to be up before that's got to be up, and they don't generally do that. But it will warn you that something's gone wrong, and I'm waiting for it to start it. All right. Question?
That volume and that network that you described in the post file, those assumed to be pre-created already? Or?
No, they're not pre-created at all. So if you have a look at the bottom here, you see there's the volume that I created, and there's the network that I created over there. It's a good point. Thank you very much. Thanks for the thought. Throw it up. All right. So no, they're not. They're created there. But this element now gives you, again, coming back to infrastructure as a code. I can check this in. Somebody else can pull it out, run this, and they'll have the elk stack running on their machine in no time at all. All right. So just to try and drive this point home a little bit more, that my life before Docker was create all of these different environments, install, configure, maintain these complex applications. My life now with Docker is install and configure a Docker image and then push the image to my laptop, to a test server, to a live server, and it's made my life absolutely, well, I can't say completely blissful, but it's generally better than it used to be. All right, so getting started, and this is the last slide before we close out. Linux, Windows, Mac, and this is the age-old debate. Where do you go? How do you do it? I've spent most of my morning talking about Linux and talking about the subsystems and the underpinnings, because I believe that if you're going to get into Docker containers, you're going to get into this open source world, I think you need to spend some time, even a small amount of time, understanding Linux and getting inside Linux. The best container images are on a Linux environment. The smallest container images are in a Linux environment. Don't be scared to jump in and get in there. To start on Linux, you just get the community edition of Docker, download and install, get Docker Compose. Very well documented, very easy to do. A few lines of code. You can push them into Bash script and rerun them in whichever environment you want. Windows is a bit more tricky. So Windows has a couple of options. In the olden times, I'm talking a year or so ago, we used to use Docker tools. And basically that was an application that ran on top of VM VirtualBox. Right, so you needed to install VirtualBox, or it would install VirtualBox for you, and then it would create an environment inside there that actually ran and simulated this kind of Linux-y type of boxing off elements, right, inside the Windows environment. On Windows 10, you can now get Docker for Windows, which now starts baking all of that goodness. You don't need VirtualBox on your machine anymore. You can actually run You can run it on the Windows 10 box, and it connects as if it was doing the more Linux-based stuff, so they've invested heavily in it. But there's some caveats, as there always are when you're working on a Windows environment. If you install Docker for Windows on a Windows 10 box, it uses hypervisor, and then your VirtualBox is gone. You can't use VirtualBox anymore, right? Which is, you might say, yeah, it's not such a problem. The real trick is that if you're getting into this Dockerized container stuff, the small versions of Kubernetes, which I want to show you in the talk after the next one, needs to run on a VirtualBox, and if hypervisor is missing, then if hypervisor is enabled, then it doesn't run, and so you can't get into playing with Kubernetes unless you've got the kube available in the cloud. So it just starts narrowing down where you go. I'm not saying don't get started, but the Windows option does offer a few bottlenecks. My suggestion here is install VirtualBox, you get a version of Ubuntu onto your machine, and start playing with Linux in a virtual machine environment. And you can map your drives, you can map across your ports. It's relatively easy to get going. On Mac, because Mac is based on loosely on the Linux kernel, it's actually quite trivial. It works pretty well. All right, so it's just this middle child. I don't know.
So Chris,
Yes.
have you tried running that Windows subsystem for Linux? Is there any benefit? Or?
The Windows subsystem for Linux, okay, so let's just be very clear. This is a Linux machine, okay? So my Windows machines are virtual machines now. So that's the Windows 10 environment. I've tried to run it, try to get it going. I've battled uphill, and so I have had people that are happy with it. Yeah, so if anything's going to take me longer than 10 minutes, I generally get frustrated with it and then move on. So I had some issues because I had to connect to the store and do something and pull something down, and it just gave me a nightmare. So I moved on. It could have been because I was running in a virtual machine. I can't remember, but your question was, have I tried it? Yes. Didn't have good luck with it, but do I know people that have had good luck with it? Yes. Yeah. So that does work, and it gives you the more Linux based feel. I'm interested to see what Linux does in the next, based on that. I'm interested to see what they do with the next version, as to whether they bring some element of the Linux kernel into the operating system. But we'll see on that. We've got a very cool going, so everyone wants to join that. All right, so that's getting started. I just wanted to bring back, as a closing argument, why you would want to consider going into Docker. I'm not going to walk through all of those things, but to remind you on that. And with that, I'd say thank you very much. My next event, I haven't set a date, but I've hinted at it heavily when we were talking about the elk stack, about using Logstash, Elasticsearch, and Kibana to read your log files and surface up some information, knowing where your clients are, what they're doing on your system. It's a really interesting talk. It's already prepared. It's already going. So that's going to be the next event, I guess, in the next 2 months. And then one after that is to talk a little bit about Kubernetes, how to get started on your local machine, where we want to go. And I'd like to do that before the end of the year. So expect 2 more events this year. Great. With that, thank you very much. I don't know if there's any questions. Question at the back.
Just your question on orchestration tools that you spoke about Kubernetes on Windows machines. Does Minikube not provide an answer for that?
Minikube does, and that's exactly what I was talking about. So Minikube runs in a virtual machine on Oracle's tool.
Yes.
VirtualBox. The problem is that if you're running Docker for Windows, it turns Hyper-V on, and VirtualBox stops running, and so Minikube doesn't run anymore. So yeah, you run into
Still have the same problem then.
Yeah, you run into these terrible, it's frustrating. Yeah.
So just the cloud instance then.
No, I think you can do this stuff locally, just choose a real operating system. Sorry, that's what my team hears all the time. you want to for bringing up Minikube. Sorry, it's a hazard being in this. Anybody else? Nothing. Guys, thank you very much for coming out this morning. It's been great chatting to you, and we'll speak to you soon.